This is the last example for this lecture. Here's a serial connection of a resistor and a coil. The RMS value of the port voltage is 115 volts. The RMS value of the resistor voltage is 55.4 volts. The RMS value of the coil voltage is 80 volts. The working frequency of the circuit is 50 Hz. We also know that the resistance is 32 ohms. Now we are interested in the inductance and the parasitic resistance of the coil. According to the frequency, we know that the angular frequency is 314 rads per second. There might be two possible solution methods for this problem. One is that we list the equations for these circuits. Specifically, the current I is equal to U over the whole impedance, like this way. Because we know the RMS value voltage over 32 ohm is 55.4 volts, we can find this. Next, the input impedance and the current of U2 have such a way. We also know that U equals 115 and U2 equals 80. Then we can solve the nonlinear algebraic simultaneous equations about R2 and L. Yes, we can do it this way, but it's too mathematical and time-consuming in the solving process. Next, let's see how to solve it with phasor graph elegantly. Let's set I as a reference phasor. We know that U1 and I are with the same phase. In U2, we suppose that this is UR and this is UL. We can draw the phasor graph with head-to-tail method. That means that UR and I are with the same phase. UL is leading I 90 degrees, so this is U2. U1 plus U2 equals U. We know the length of this is 115. This is 55.4, and this is 80. So we know all the side lengths of the triangle. Then we can find all the degrees. For example, we can find this angle phi through cosine theorem. Next, we know that theta is this. With theta and the whole circuit, we can solve the problem. With the angle, we can find UR and UL value easily. With the current, we can find R and L easily. You may compare these two methods. You can find that the phasor graph method is very intuitive and very simple. We encourage you to draw the phasor graph often. In this lecture, we discuss applications of the phasor method in SSS and time domain analysis of dynamic circuits. You may find that with phasor, the circuit can be represented by an algebraic equation with complex coefficient. It is very important. Okay, this is the end of this lecture.